Hello, today we are going to be talking about scale drawings. So a scale drawing is a diagram or map or model of an object that is too large or too small to draw. The dimensions are proportional to the actual dimensions of the real life example. So some examples could be maps, blueprints, floor models, and some other things. So as you guys can see, here's like a floor plan model. They have the family room, the living room, the kitchen, and the dining room. Or as you can see over here, they got some streets talking about like a city. So these would be examples that would be too big to draw on an actual paper. So you just create a scale drawing of it. Then when you create scale drawings, you have a scale on a scale drawing that is used for the ratio of the drawing lengths or model to its corresponding actual lengths. So 1 inch 12 foot means that for every inch in the model represented, it has an actual distance of 12 feet. So for example, for this, it says 1 to a ratio of 10,000. So 1 inch would be equivalent to, and they put 833 feet. Or for example, for here, 1 inch is 12 feet. So for every 1 inch on this scale drawing, it is equivalent to 12 actual feet. Okay, so let's do some examples. So to find the actual distance from a scale drawing, use the scale to write a proportion and solve. So example 1 here says, on a map of Florida, the distance between Coral Springs and Fort Lauderdale is about 4.1 centimeters. The scale on the map is 1 centimeter to 4.5 kilometers. What is the actual distance? So whenever, once again, you see 3 numbers in a problem, you guys should know right away that we are going to set up a proportion, okay? And how I teach it is your first proportion is always going to be the scale. So whatever scale that they give you, write it as a fraction. And it's easy if you guys go ahead and label them as well. So we have 1 centimeter over 4.1 or 4.5 kilometers. Okay? Then we are going to use this to set it equal to our other fraction in our proportion, and we're going to look at what they gave us. So it says on the map the distance between Coral Springs and Fort Lauderdale is about 4.1 centimeters. So remember, in a proportion you have to keep everything aligned. So since we're talking about centimeters and centimeters was in the numerator, you also want to keep centimeters in the numerator over here as well. Okay? Then we are trying to find the actual distance, so that's what we're trying to find in the denominator, so we are going to put x, okay? And when you guys set up proportion, it's always going to be the scale over the actual. So as you guys can see, the scale had 1 centimeter, the actual was 4.5 kilometers, okay? So that's another way that you guys can tell if you're setting it up correctly. So remember, to solve a proportion, all that you have to do is cross multiply. So 1 times x is just 1x, or in other words, just x. And then 4.5 times 4.1 gives us an answer of 18.45. So our answer here is just x equals 18.45 kilometers. Okay, so let's try another one. So on a map of North Carolina, the distance between Raleigh and Charlotte is 3 1/4 inches. The scale on the map is 1 inch equals 40 miles. What is the actual distance? Okay, so again, I see 3 numbers and I'm trying to find an actual distance, so I know I should set up a proportion. I'm going to start with the scale that they gave me, so 1 inch equals 40 miles, and set it up as my first fraction. Then I'm going to use the other number that they give me to place it in my second fraction and solve for the missing variable. So between Raleigh and Charlotte, it's 3 1/4 inches. So inches is our scale, or in other words, our numerator number. So 3 1/4 would be up there at the top. And then we are trying to find the actual distance. So x goes in the denominator. Okay, so now that I set up my proportion, I can just solve. So 1 times x is just 1x, or just x. And 40 times 3 1/4 is 130. So our answer is 130 miles. All right, and then our last example. So on the blueprint of the pool, each square has a length of 0.25 inches. What is the actual width of the pool? So notice now that they give us the scale on the blueprint. So they tell us that the scale is 0.25 inches is equivalent to 2 feet. So that is going to be my first fraction in my proportion. So 0.25 inches over 2 feet. And they don't give me another number because they give me my blueprint. So I need to figure out the length of it myself. So what they're telling us is that every square, so every length of the square, has a length of 0.25 inches. So this first square has a length of 0.25. Then add on another 0.25 and we now have 0.50. Because 0.25 plus 0.25 is 0.50. Add on another 0.25 and we get 0.75. Add on another 0.25 and we get 1 inch. So from here to here it's 1 inch. Add on another 0.25, we're now at 1.25. And then add on one more 0.25 and we're at 1.5. So the distance of the pool has a distance on the map of 1.5 inches. So that's the number that I'm going to use in my proportion. So 1.5 inches over x, which is what we're trying to find. Another way to do this is if you knew that every square was 0.25, just figure out how many squares you have that made up the length of the pool. So you have 1, 2, 3, 4, 5, 6. So if you just take 6 times 0.25, you would get that 1.5 again. Okay, so let's go ahead and solve this. So 0.25 times x is 0.25x. 2 times 1.5 is 3. And then last step to get x by itself is to divide by that 0.25 on both sides. And 3 divided by 0.25 gives us 12 feet. All right, so we do have a couple more examples on the back. So for number 4, a designer has made a scale drawing of a living room for one of her clients. The scale of the drawing is 1 inch equals 1 1/3 foot, and the drawing on of the sofa is 6 inches long. Find the actual length of the sofa. So once again, I see my scale here, and I know that I'm setting up a proportion because I see 3 numbers. So my scale is going to be my first fraction in my proportion. So 1 inch and 1 1/3 feet. Then I'm looking at my other number and looking at, is that part of the scale, the drawing, or is it the actual length? So notice how the drawing, so that would be the scale, the blueprint in other words, was 6 inches. Notice how inches was in the numerator, so I'm going to keep it in the numerator. And then I'm trying to find the actual length. So again, all that we do is cross multiply. So 1 times x is just 1x, or just x. And then 6 times 1 1/3 will give me 8 feet. Just so you guys know too, some calculators don't allow mixed numbers to be plugged into their calculator. So for example, mine does have it. So like here's my fraction key, and then right above it I can put in a mixed number. So I could hit shift and then my fraction key, and notice how it would bring up my mixed number for me. So I could type in 1 1/3 times 6 to give me that 8. But just know some of your guys' calculator, you won't be able to put in a mixed number. So you might have to plug in a improper fraction. So like 3 times 1 is 3, plus 1 is 4. So this would be 4/3. So 1 1/3 is the same thing as 4/3. So you would have to take the improper fraction times 6 to get the same answer. Okay. All right, so number 5 is a little different. So it says, inside the Lincoln Memorial, the chamber that features the marble statue of Abraham Lincoln has a height of 60. Suppose the scale of the model of the chamber has a height of 4. They want us to find the scale of the model. So notice how we only got 2 numbers, so we know we aren't setting up a proportion. All that they want us to do is to just find the scale. So in other words, the scale was taking whatever inch, so it's always one of something, is equivalent to whatever it's representing. So when you write a scale, again, the ratio is always the drawing or the blueprint or whatever it is to the actual. So when I set this up as a fraction, it said that the scale model of the chamber had a height of 4, so that would be my drawing, so my scale model. So 4 is going to go in the numerator, and then the actual is always in the denominator. So if I wanted to figure out what scale they use, you're just finding a unit rate. So remember, a unit rate is when you have 1 in the denominator and then you're trying to figure out the, 1 in the numerator and you're trying to figure out 1 in the numerator and you're trying to figure out the denominator. So all that you have to do is just divide. So if you take 4 divided by 4, that gives you 1, and that's what we wanted. Then if you take 60 divided by 4, you get 15. So your scale is 1 inch to 15 feet. So for every inch on the scale model, that represents 15 feet. So just be careful of what they're asking. Notice when they give you 3 numbers and you're trying to find a scale of something, or the scale model or the actual length, that's when you're setting up a proportion. If they're just asking what the scale of the model is, you're just setting up a fraction as the ratio of the scale over the actual and just dividing to get that scale. All right, moving on to scale factors. So to find the scale factor of scale drawings, you write the scale as a ratio, showing the scale length to the actual length, so exactly what we did up here. Make sure that you change the lengths to the same unit of measurement, and you always convert the bigger unit to the smaller unit, and then you simplify. So for example, A here says, suppose the scale model has a scale of 2 inches equals 3 feet. What's the scale factor? Okay, so first step is writing our scale as a fraction. So 2 inches equals 3 feet. Second step is to change the lengths to the same unit of measurement, and we are always going to convert the bigger unit to the smaller unit. So in this case, feet and inches, feet is our bigger unit, so we need to convert feet to inches. So you guys need to know how many feet are in an inch, and if you don't remember, there are 12 inches in every foot. So if I want to convert feet to inches, okay, I have 3 feet, so if there's 12 inches in every foot, I'm just going to take this 3 times 12 to change it to inches. So 3 times 12 is 36. So my new scale is now 2 inches over 36 inches. Okay, and then scale factor, you want it to be 1 in the numerator, just like we had up here, so 1 over something. So remember, to do that, all that you have to do is divide. So take numerator divided by denominator. So 2 divided by 2 is going to give me 1, which is what we wanted. And then 36 divided by 2 is going to give me 18. So our scale factor is 1/18. Okay, moving on to our next example. So identify the scale factor. So again, we have our scale, which is the blueprint, and the actual, which would be represented as the room. So notice how they give us 2 sets of numbers, so it doesn't matter which set that we use, but I can demonstrate how it's going to work for both of them. So notice how we have the length, and notice how we have the width. So the length, again, it's always the scale, so 18 over the actual, 144. And to figure out the scale factor, notice how it is already in inches, so both labels are in inches, so we don't have to convert anything. We can just divide like normal. So 18 divided by 144, 18 divided by 18 is going to give me that numerator of 1, and then 144 divided by 18 gives me 8. So this will have a scale factor of 1/8. And even if you use the width, so doing the same thing, you're taking the blueprint, so 13.5, over the actual, so 108. And if you were to simplify this again by dividing, 13.5 divided by 13.5 is 1, and then 108 divided by the 13.5 is going to give you 8 again. So notice how your scale factor stays the same when you're talking about the length and the width of a room. All right, last question here. So use the scale 2 inches to 5 feet to find the measurements for the height of the entire structure and the height of the sidewall on a set of blueprints. So we notice how we're going to have to do a couple of different proportions here. The first one is they want us to find the height of the entire structure. So that means the wall and the roof. Okay. So again, when you're given your scale, remember you are always starting with that scale as a fraction, so 2 inches over 5 feet. And you're going to set it equal to whatever you are trying to find here. So notice that the actual height of this house is 20 feet for the wall and 12 feet for the roof. So if they want us to find the height of the entire structure on the blueprints, the entire structure, we need to add both of these measurements together because they want the whole thing. So if the wall was 20 and the roof was 12, add those two together and you get an entire length of 32 feet. So in my fraction, remember actual goes in the denominator, so I'm going to keep 32 in the denominator, and then x is going to stay my numerator. Okay, so this will be the height of the entire structure on the blueprint, so let's go ahead and solve. So 5 times x is 5x. 32 times 2 is 64. And then to get x by itself, just divide by 5 on both sides. So 64 divided by 5 is 12.8. And notice how this time we're finding the blueprint, so it'll be 12.8 inches. So this represented the height for entire structure. So the next thing they want us to find is just the height of the sidewall on the blueprint. So the sidewall only had a height of 20 feet. So we're going to do the same exact thing. So we're going to set up the proportion again. So we're going to start with our scale of 2 inches for every 5 foot. Okay. Then this time we only want to find the sidewall on the blueprint. So this time I only want to use 20. And that was on the actual, so actual goes in the denominator, and we're trying to find the blueprint. So x goes in the numerator. So now we just cross multiply, so 5 times x is 5x. 20 times 2 is 40. Divide both sides by 5, and 40 divided by 5 gives us 8. So on the blueprint, just the sidewall itself would be 8 inches. And that is it. So if you guys have any questions, please let your teacher know.